Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at Venn diagrams. So, what is a Venn diagram? It's just a tool to help us in probability. So we're going to illustrate it with an example. So let's say in a class of 22 students, 8 scored an A in maths, 9 scored an A in science, 10 did not score an A in either of those subjects. Represent this information in a Venn diagram. So how would I know to use a Venn diagram in this situation? You use a Venn diagram when you're doing a question that involves different sets. Sets in maths are just collections of objects. In probability, collections of events. So what we want is a rectangle here, and we have two circles representing each set. The set in these questions, first one is those who scored an A in maths, and the second one is those who scored an A in science. So I'm going to call my two sets M, that's people who scored an A in maths, and S, the people who scored an A in science. So we draw the Venn diagram like this, and we're going to populate it with four numbers. The number of people who scored an A in maths only, an A in both subjects, an A in science only, and then an A in neither goes outside the circle. Venn diagrams just allow us to visually represent how many elements, how many things basically, are in one set, both sets, or neither set. And from that, we will be able to use it to perform calculations in probability. So, as I said, we need to populate this with four numbers. One here, 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 and here. So you might be wondering, hang on a minute, 8 plus 9 plus 10 definitely doesn't equal 22. It equals 27. How can you possibly have 27 students when the class only had 22? Well, of course, there are some students who are in both. How many are in both? Well, because 8 plus 9 plus 10 equals 27, we have overcounted by 5 students. The only way this is possible is if I counted 5 students in the maths category and then counted them again in the science category. So however many you have overcounted, go in the middle. That's the number that's both. Because I overcounted by 5, 27 is 5 more than 22. There must be 5 students in both sets. So now I can populate the rest of the numbers. So it said 8 scored an A in maths. So I want 8 inside this maths circle. I already have 5 inside the circle, so I need 3 more. Similarly, I want 9 inside the science circle. I already have 5 in the circle, so I need 4 more. So the 10 that scored an A in neither go outside. Notice 10 plus 4 plus 5 plus 3 does equal 22. These numbers should add up to the original number of, in this case, students that we had. So we've just represented visually how many are in each set, how many are in both sets, neither set. That's what Venn diagrams are for. So now we can answer some questions on probability. So let's start off by calculating this, the probability of M something S. What does this something mean? Well, this is the mathematical symbol for intersection. So the intersection of the circles is here. We're finding out basically the probability of being in this middle segment there. So this means the number of, in this case, students in both sets. So when you see this symbol here, I want you to read it as and. The probability of M and S. If we select a student at random, what is the probability they scored an A in maths and in science? So this is just those who scored an A in both. There are 5 such students, and there are 22 in total. So now we're going to calculate this. Well, what does this symbol mean? See, it's like an upside down version of that. Well, this U looking thing here is the mathematical symbol for union. So the union of two sets is everything that is in one or both sets. So in terms of the Venn diagram, That is everything inside the circles, because everyone here, here, and here is in at least one of the sets. So in terms of our question, this is anybody who scored an A in maths or science or both. So when you see this symbol, I'd like you to please read it as the word or. Remember, we learned in a previous video that when we're doing probability, or includes both. It doesn't mean just this or this. We also include the number of students in both sets. So the probability that a student selected at random scored an A in maths or science is 3 plus 5 plus 4. There were 12 students in total who scored an A in either maths or science or both. But of course, probability can't be a whole number like 12. It needs to be over the total, over 22. So if you're giving it as a fraction, make sure it's simplified. So 6 over 11. So let's calculate the probability of M. See, people often make a mistake here. There's not just 3 in M, you also have to include this part. There are actually 8 in the M circle, as there was in the question. So probability of M is 8 over 22. Again, we simplify it if we're writing a fraction. So remember, probability of M dash means the probability we're not in M. So if 4/11ths of students were in M, that means 7/11ths are not in M. So what about this? This says the probability we're in M and not S. In other words, in M only. The probability if I select a student at random, they scored an A in maths and did not score an A in science. Well, that's just those 3 there out of 22. What about if we then find the probability of M or not S? So in this, we include anybody who scored an A in maths, so that's these 8 people, and we also include these 10 because they didn't score an A in science. So 3 plus 5 plus 10 is 18 out of 22, which simplifies to 9 over 11. So as a general rule, when it's a question involving and, there's going to be one number you need to procure from the Venn diagram, and when it's an or, there are 3 numbers that you need to get. Here we included 1, 2, 3 numbers. So let's calculate this. Probability of M something S. When you see this symbol, I want you to read it as given. The probability of M given S. What does this mean? It's saying I know S is true. What's the probability that M is also true? This is saying what's the probability that somebody scored an A in maths if I know that they scored an A in science. So I'm saying I know that they scored an A in science. So I know I'm picking one of these 9 students. Of those 9 students here, how many scored an A in maths? Well, that's 5 of them. 5 out of the 9 science students scored an A in maths, so the probability there is 5 over 9. All right, let's now look at an example involving 3 circles in a Venn diagram. So in this example, we have 3 sets, students who play basketball, AFL, and soccer. So we set up our Venn diagram like this. So I'll just call that AFL, basketball, and soccer. So let's go through and add in the numbers from here that we do know already. Well, we know 3 play all 3 sports, so I can put a 3 there. We know that 7 play both AFL and basketball. So AFL and basketball together is this intersection here. We already have 3 in this area, so we need 4 more to make 7. Similarly, we need 7 to go here. So there are 10 people here who play AFL and soccer. So because there are 28 people who play AFL, I've already got 14 in the AFL circle. I need another 14 there. I also have 173 that play neither. Now I can't fill in these numbers yet. Here's the problem. For basketball, we know that there are 32 people who play. We know these two numbers add to 25, but we don't know how it goes. It could be 16 and 9 or 11 and 14. We just don't know. We don't have enough information merely from this. What we're going to do is set up an equation. I really need to find this number. I'm going to call it x. So because these two numbers add to 25, this number is just 25 minus whatever that is. So this will be 25 minus x. Similarly, I need 30 in the soccer circle because 30 plus 10 is 40. So this will be 30 minus x. Now I'm going to set up an equation. So I have 28 in the AFL circle, 173 outside the circle. And then if I add those three numbers in yellow, all of these need to add up to 250 because that's how many people there are in total. So let's go ahead and solve this equation. Well, 28 plus 173 plus 30 plus 25 is actually 256. X minus x minus x is just negative x. So I've got 256 minus x is 250, therefore x equals 6. That means there are 6 people here. There are 25 minus 6, which is 19 here. And there are 30 minus 6, which is 24 there. I now have my Venn diagram filled out, and I can use that to answer questions about probability. So the probability that a student selected at random plays soccer and does not play AFL or basketball. This is saying I'm definitely in the S circle, but I'm not in either the A or the B circle. So that is actually just this number here, 24. We are just looking at those 24 who play soccer and do not play AFL or basketball. So, of course, it's a probability. So it can't be 24, it's got to be 24 out of something. 24 over 250 simplifies to 12 over 125, and we are done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.